So this example is a little bit more complicated. We're going to be looking at a situation where the parameterization is actually quadratic, right? So each of these is a quadratic polynomial in two variables. So our x is u squared minus v squared, and our y is 2 times uv. And so if we look at what that transformation does to this unit square in the uv plane, it actually transforms it into this crazy region here that's sort of bounded by these two parabolic curves. And you might be wondering, how the heck did I get that? So let's step through it in a little bit more detail. So over here where we've got u equals 0, the image of u equals 0, what does that look like? Well, we're going to have x equals minus v squared and y equals 0. So this lives entirely in the plane 0, and so in the x-axis, the y equals 0 line. And so what we're going to see is we're going to start at the origin here, and we're going to go faster, increasingly faster, because it's squared, and we go in the negative direction. So, and then what about this one over here where v is equal to 0? So this is the same kind of thing. So then we've got x is equal to u squared and y is equal to 0. So now we're going to start here, and then it's going to be we're going to go in the positive x direction this time, and we're going to go slowly faster and faster and faster and faster as we like shoot off into the distance because it's speed increasing quadratically. Okay, now what about the orange here? So this is where, whoops, oh yeah, no, I was right. U equals 1. Okay. So then that means we're looking at the curve where x is equal to 1 minus v squared and y is equal to 2. 2v. Okay, and so that's going to be a parabola opening toward the left because this is negative. And you can see that if I were to choose something else, like just for grins, let's suppose we did like this one right down, oh, that didn't even show up. This one right here, right down the midway, so that's where u is equal to 1/2. So for that one, we would have u equals 1/4 minus v squared, y equals v. And so you'll notice that the horizontal speed is the same, but now the vertical speed is half of what it was before. And so that's why you see that this parabola here is kind of blunted. It's actually, if you look at it, it's midway. So this curve here is midway between this curve and here. Okay. And then of course there was the last one, the purple guy, that's where v is equal to 1. And so we also have, what is it? So that's x equals u squared minus 1, and y is equal to 2u. Okay, and that gives us this guy here. All right. Okay, so that's how we got this region. Is this the sort of thing that you'd be intended to or expected to come up with on an exam? No. I would give you the transformation. I would not give you this region and ask you to figure out the formulas that go with it. And this one, in the previous example, we could actually like invert the transform and work backwards like that. That doesn't go so well here. It is possible actually to invert this one. You have to kind of go piece by piece, but it's got so many square roots, it would just, you'd never forgive me if I showed it to you, so I'm not going to do it. So let's see. So RU cross RV is going to be giving us our Jacobian for this one. So we have I hat, J hat, K hat as per usual, XU, XV, and 0, YU, YV, and 0. Again, 0 is because we're just parameterizing a region in the plane, so it's got no z coordinate. The z coordinate is 0. So this gives us our 0, 0, and then you have dx, du, dy, dv minus dx, dv dy du. And so our Jacobian for this guy is just this term that shows up in the third component, the k component of this cross product. So we get, let's see, maybe I'll back up. Okay, so we get 2u and where are we? Minus 2v, and then 2v and 2u. Okay, so that gives us 4u squared minus negative 4v squared. So there's our Jacobian. All right. So now the integral that we're going to compute with this one is the double integral over the region R of y dA, where the R is bounded by y equals 0 and y squared equals 4 minus 4x and y squared equals 4 plus 4x. And so that region is just this thing that we cooked up a moment ago. It's this one. And like I said, this is a situation where if I gave you this integral, I would also give you the coordinate transform that you need. And I would say, okay, here, do this integral by using this coordinate transform, because otherwise that would be mean. So let's see. So based on this, well, we already figured out now that this is between u equals 0 to u equals 1, v equals 0 to v equals 1, because it's over the unit square. And y is just 2uv. And then our Jacobian is 4u squared plus v squared. And that was dv du, or du dv. It's over a rectangle in uv space, so it doesn't actually matter. So let's see. So then this is going to be, you could pull out the 8, and you've got 0 to 1, 0 to 1. U cubed v plus uv cubed. And then it's just a matter of integrating a polynomial. I won't bore you with the details. If you're following along at home, you can check it out. It's 2.